Hi everyone. So let's talk about gravitational force or force of gravity. So the universal gravitational force formula is this, where G is a constant, universal constant of gravity. So it is 6.67 times 10 to the minus 11. And as you can see, this number is really small. So when you say gravitational force, you actually have under effect of this by all other objects around you because everything has a mass that you're seeing around you. So therefore whenever there is a mass object with a mass, another object with a mass, and there's a distance between them, that's the d, there is a gravitational force. But the fact that you don't feel that your table or your computer or cell phone doesn't attract you that much, the fact that you don't feel it is because of the fact this gravitational constant is 10 to the minus 11. It's really small. So observable effect of the gravity comes into play when these masses are extremely big to overcome this constant, such as sun, earth, moon, that kind. So we see this, astronomical observations of planets, rotating around the sun and all other planetary systems and other galaxies. Um, like collective movement of the different stars around the galactic center, all of it comes from the gravitational force because the masses in these systems are incredibly big. Therefore it's producing something that we can observe naturally. So since I mentioned sun and earth, for example, I mentioned in this centripetal acceleration video, so sun basically causes all the planets circulate around itself due to gravity, just like earth, right? So in that case, the centripetal force was basically due to gravity. So we did mention that in the previous video. And Earth's own mass is really big, as you know. So when you think about yourself, let's say this mass 2 is you and mass 1 is the Earth. So you're walking on the Earth, right? So you're walking on the Earth means you're basically distance to the center of the Earth is radius of Earth. So if you change this mass 1 to mass Earth and distance, your distance to the Earth is the radius of the Earth. And as you know, we know these numbers like what is the mass of the Earth, what is the radius of the Earth. G is a constant that is known anyway. So you do this multiplication, and what you get is, I guess some of you can guess that, is the gravitational acceleration G, 9.8 meter per second square. Okay, so basically the force of gravity on you is your weight, right? That's what you call weight is force of gravity on you, weight. And I did mention this at some point, stating that what you measure here in US is your weight, whereas the rest of the world, which uses SI, international system of metric system basically, is measuring mass instead of weight. But here you measure it, you measure weight. So gravitational force exists between all objects that has mass. It's always attractive. It's never repulsive. So these are the basically key elements. So it depends on the masses of the objects and distance between them. So when you look at the form of the, let me write this again here, gravity is, or the capital G, maybe. It's basically the constant mass of the first object, mass of the second object, and the distance square. So there are questions in your homeworks, I believe, asking you how does, if you double the mass of one of the object, how is it going to affect the total force between them? If you make M1 as 2M1, you can see directly, it's directly proportional, force is directly proportional to the masses, so it's going to double the force. But if you double the distance between them, you can basically see that the distance here is going to be 2D, but distance has a square. Therefore, if you double the distance, keeping the masses the same, the result of the force is going to be, let's call it F prime G M1 is the same, M2 is the same, but D becomes 2D. So if D was 1 meter, it's going to be 2 meters. So I'm just going to write 2D here. But the distance is 2D now, but it needs to be squared. So if you square 2D, what you get is 4D squared, right? You need to square both of these terms. Therefore, F prime is going to be G M1 M2 divided by 4D squared, right? So basically you can see, look at these two and conclude that Fg, the original force, is 4 times bigger than Fg prime, right? That's the relation. Like you can see that this is what you call Fg, right? This is the original value, whatever the value is. So let's say it's 10 Newton. Then it means your Fg prime is going to be 2.5 Newton because it's 1/4 of it. Okay? So that is basically how you solve these proportionality problems. You just look at it. If it says double the distance, you put 2D. You can just take the D as 1 and 2D as 2 just to see the proportionality. I just try to solve a problem that might basically come across in homework, so I hope that will help you to understand how gravitational force problems work. Let me know if you have questions. Have a good day.